Okay, so let's wait for 5 minutes and after that we will start. So, am I visible? Deepak?
Yes, yes, please.
Actually, am I visible or not? Can you see me?
Yes, sir. Yes, you visual, your background screen or maybe PT, I can see.
Yeah, everything. Okay, okay. So today actually I'm having something different on my screen actually. That's
Yes,
why
yes,
I'm
I can see the different presentation.
okay.
Is there to, is
What is
this
the
tool,
difference?
is this separate tools or maybe like it is already in MS Team?
No, what is the difference actually? Please elaborate.
Difference, I can see you as well as in background I see PPT.
Okay, okay. So you can okay, okay. You are like both are together actually.
Correct.
Yeah, yeah. Actually, it's in the option in the team itself. Yeah.
Yeah, earlier this PPT Miss Pratibha Singh, the same way I can see you.
Okay, okay. Thank you, thank you, thank you for confirming this. Yeah.
I'm just asking you, is this tool here, this facility is available in MS Team?
So actually, it's available in the MS team. So in
Okay,
this, there is a option of change your view option is there.
okay,
So yeah, in that, if you go there, then you can pick some settings and then it is there actually. Yeah.
yeah, okay. Focus on content or more option.
Yeah, in more
Okay,
options. Yeah, yeah, yeah.
okay. So gallery on right, turn on incoming video. Turn off your add shared display. Okay, maybe you use add shared display.
Actually, I have to next time I will I will also check the option. But I think the thing is that turn on incoming video. I think that's the option.
Okay,
Yeah.
but this option is good. I'm just writing in group because the Subrata group there is a few guys is there from hydrogen this hydrogen storage course or hydrogen energy course. So I'm just writing them. If anybody want to join, they can join.
Yeah, yeah, sure, sure.
Today's session is going to start. Going to start. Start. Yeah, I just copy paste link. Uh, copy link. Copy link and
Yeah,
post.
please mute yourself, Deepak. Yeah.
Yes.
Okay, so we have waited enough. Now I think we should start. So good evening, everyone. I welcome you all to the live session number 10 for the course content for the course Hydrogen Energy Production, Storage, Transportation and Safety. And currently we are in week 10. The course instructor is Professor Pratibha Sharma from IIT Bombay, and I'm this course T. Amit Kumar Sharma. So as you all know that normally on every Sunday, but this time due to some due to some changes in the plan, so we are not having class on Sunday. So normally every week we have a class in which I discuss the previous year's assignment question so that you can see how to solve the assignment question and you can have a quick go through the previous week's course content. so that you can have a kind of revision. We can also discuss in this class. So if you have any doubt, we can discuss that also. And those who are having any doubt for the previous classes, they can email me. This course PPT and the video will be shared to you from the NPTEL team. So those who are not able to attend today, they can use the content later. Okay, so let's start with today's class. Okay, so this is the course outline. As of now, we have covered the production, we have covered the storage. Okay, now we are in transportation. So this week, so in the previous week, we have covered about the transportation. So today we will go through this section. The question number one is the entropy of mixing for a high entropy alloy can be calculated using which formula? So if you have gone through the class content, then you will remember the formula. So these are the options A, B, C, and D. Try to remember and let me know the answer. Okay. So the answer is option A. So this is the correct formula by which we can calculate the entropy of a calculate the entropy of mixing for a high entropy alloy. So this was covered through this slide. So in for the phase prediction rules for the high entropy alloys, these are used for predicting and understanding the microstructure. So for thermodynamic parameters, the entropy of mixing delta S mix minus R summation of I to N Ci ln Ci. So this is the formula for enthalpy of mixing. This is the formula. Okay. So try to remember these. Maybe you can have any numerical regarding this regarding this formula in your assignment or in your exam. A high entropy alloy should have minimum of how many elements? 4, 5, 6, and 8.
Five. Actually, this same PPT already we see in previous class, previous
Okay.
session.
Okay, okay,
Hmm.
okay. So you have already like okay, okay. Because normally
Yeah.
we have two sessions, so in that you have already
Yes.
covered. Okay, okay, no issue.
But
So
but before eight session, your slide and Mr. Subrata's slide was different. But last two slide session is same slides is showing by both of you.
okay, okay, okay. It's kind of a coincidence then. Yeah. Okay. So we have one answer. Option B. Anybody else? Okay. So the correct answer is option B. 5. So for high entropy alloy, there should be minimum 5 elements. Now let's see more about this. So in the recent year, high entropy alloys have been attracted the worldwide attention in the field of hydrogen storage due to their unique microstructure and extraordinary physical, chemical, and mechanical properties. So due to these properties, we are considering these high entropy alloys HES. So in 2004, JW and Brian Cantor independently published the report and article on high entropy alloys and equiatomic multi-component alloys, as well as a dependent publication by S. Ranganathan, introduced these alloy globally. So these are the scientists who contributed so much in this field. And high entropy alloys, also known as multi-principal element alloys and complex concentrated alloys. So you can also see these names instead of HES, MPES, and CCS. The multi-principal element alloys and complex concentrated alloys. So what is the definition? So definition is the HES are mainly defined based upon the composition and entropy, okay, or configurational, you can say. So composition and entropy, with these two, they are defined. So for the composition based definition, the alloy which is having at least 5 elements. So there should be at least 5. So there can be more than 5, no issue, but at least 5 elements should be there. And each of the element having the atomic concentration between 5 to 35%. It's also important. So there should be at least 5 elements, and each of element having the atomic concentration between 5 to 35% is defined as the high entropy alloys. Based on the entropy based definition, so if the configurational entropy of alloy at random state is greater than 1.5 R, no matter if they are single phase or multi-phase at ambient temperature. So the entropy should be greater than 1.5 R, where R is the gas constant. Okay. The configurational entropy is should be greater than or equal to 1.5 R. So if this is greater than only 1 R, then it's medium entropy alloy. If it is less than R, then low entropy alloy or conventional or traditional alloy. So this is the difference actually. Which methods are not used for producing hydrogen from NH3BH3?
C.
Thermolysis, hydrolysis, chemisorption, and D, hydrocoupling.
Absorption.
Okay, we have an answer. Chemisorption. Option C. Anybody else? Think about it. So what is your reasoning behind your answer C?
Only just remember because yesterday class.
Okay, okay, okay. Okay, so the correct answer is option C. So now we will go through some slides and then you will get to know the reason. Okay, let's go through those slides. So first, what are the methods for preparation of HES? Okay, so the fabrication of HES can be possible through 3 routes using solid mixing, liquid mixing, and gas mixing. So solid mixing cover mechanical alloying, liquid mixing cover arc melting, induction melting, laser engineered net shaping, melting, and cladding. Gas mixing cover atomic layer deposition, pulse layer deposition, sputtering deposition, and etc. Now the characterization method of HES. So the fabricated material are mainly characterized with the following techniques like PXRD, SEM, TM, EDS, EDX, okay, BSE, neutron diffraction. The properties of HEs are the diverse characteristics of HE summarized as four core effects. High entropy due to the configurational entropy thermodynamics, severe lattice distortion due to large deviation in atomic size of element, because we are having multiple elements in the high entropy alloys, so large deviation in atomic size of element structure. Sluggish diffusion, kinetic due to lattice distortion, kinetic property. Cocktail, mechanical and physical properties. So these are the reason, because we are having multiple elements in the HES, minimum 5.
What is different between the characteristic and property?
Characterization, basically you can say it's characterizing, like when you use the SEM and EDS, you can do the surface morphology, you can characterize, okay, what is the arrangement of the things and all. Okay, but properties like the thermodynamic properties, okay, the structural properties, the kinetics, because these are the, you can say, the basic difference, like the state properties, we can say, like temperature, like pressure. For this, these are the properties for HES.
Mhm.
So the mechanical property and physical properties, they are in cocktail nature. Characterization, basically characterize the, you can say, what should I say, like if you are doing the SEM, then basically you are doing the surface characterization.
Mhm.
Okay, you can see the pores in SEM, you can see the surface texture, you can see the, like if you are having how they are, you can see the bonding and all, if you go through the magnification and all. So there are different things, the temp. So these things are used to do, or to see how they are, like on, you can say, the SEM, you can go up to surface. The temp, I don't know about the deep in, I have done actually SEM for my experiment also, so you can see the surface morphology clearly in the SEM. So these are the methods, so you can basically characterize your alloy, because in your alloy you are having multiple elements, so you need to characterize, okay, how they have arranged, what is the structure now, what is the surface now, what is the roughness, like that, what, how they are, like the pores and all. So these are the characterization. Then the properties, you can say, because you are having different elements, so the mechanical properties will be different, the physical properties will be different. Okay, due to the kinetics, the behavior will be different. Okay, so these comes under the properties. So okay,
Yes.
now the hydrogen storage properties. So single phase BCC HES, like Ti.3 V.25. So you can see here there are 5 elements. So this display maximum kinetic hydrogen capacity of 2.58%, 33 bar and 373 Kelvin. Then this HEA mainly contains C14 labs phase with small amount of cubic phase and used without any activation of hydrogen. Soft measurement, it absorb and dissolve 1.78% of hydrogen with very fast kinetic at room temperature. Then the kinetic study of a different binary HEA at 25 degree and 25 bar of hydrogen pressure reaches the maximum uptake of 2.78% within 1 minute. So here you can see the difference actually. So with the different combination of elements, the kinetics are different, the weight percent are different, okay, the behaviors are different. So things are changing. So in the complex hydride, it's lightweight storage material, cannot react directly with the hydrogen to achieve reversibility. The chemical form will be like this: metal, then the X will be like uh, your element, then the hydrogen, then based on that it will be the bond formation will be like that, then the M. So high gravimetric and volumetric capacities we can have. It also has some challenges. due to the kinetic and thermodynamic limitation. So we have different classes: elantes, borohydrides, amides, and imides. So sodium elanate. So here you can see we have NaAlH4. So with temperature, it's releasing hydrogen. Okay, 1 mole. Then Na3AlH6. Then further, if you increase the temperature, then you can see you have more H2. Similarly for lithium, magnesium, and potassium. So basically, with temperature, if you are increasing the temperature, you can release the hydrogen. Okay. Then borohydrides. So in borohydrides, you can see sodium borohydride, lithium borohydride, magnesium, calcium. So here they are reacting with the water. They're reacting with the water and releasing hydrogen. So here lithium bromide, it's directly, you can say, at temperature, the hydrogen bond, like it's liberating hydrogen. So there will be some change in the bonding and it's liberating hydrogen. Then it's also reacting with the H2O and liberating hydrogen. Similarly, this magnesium borohydride. So initially it was MgBH42, then first it's changed into MgH2, release hydrogen, and further Mg released hydrogen. So we can also tailor complex hydrides by doing the compositional alteration by substitution of anion and cations, formation of composite with other hydride, metalloid or compound, or coordination of neutral molecules to the cation of complex hydride. We can also introduce catalysts or additives to improve hydrogen absorption kinetic. Nano confinement via incorporating complex hydride into nanoporous host material to improve or modify the kinetic or thermodynamics. Now for the ammonia borane, so here you can see the question was about this. So it can react with the H2O and release hydrogen, but we need the excess H2O for this reaction. We can also supply heat and you can see the change. So you can release the hydrogen. Okay. So you can say it's hydrolysis. Then if you go to the question, so we can see the hydrolysis, we can see thermolysis with the temperature. We have also seen the dehydrocoupling. So some changes in the bond and release of the hydrogen, but you have not seen as of now the chemistry option. So the answer is C. Okay. If you compare the gravimetric capacity for this different material, so you can see the capacity is very high as compared to nanotubes and liquid hydrogen by 8%. Now a small numerical: compute the capital cost for liquefied hydrogen production for car for you have given some values: C equal to 0.5 MT per day, N equals to 3, I equals to 1.16. Try to remember the formula and put these values and let me know the answer.
It is D, I think, 11.2.
11.2. Okay. So what is the formula?
Formula is n into
Sorry.
10,000 lakh. Formula is n into capital N. Capital N. Capital cost equal to capital N into 10 lakhs into
Yep.
5.6 into C power 0.8 into I.
Okay. Okay. Okay.
Use
Let's
this one.
see. Okay. So anybody else?
Yes, yes, same.
Okay. So we
If
have we have answer as option D. Okay. Let's see. So yes, your answer is correct. So yeah, this is the formula. So those who have not calculated yet, use this formula and calculate. It is a formula to calculate the cost for liquid to liquefy the hydrogen, where n is the number of liquefiers, C is the liquefier design capacity,
in this
MT per
formula
day.
is not need to use 10 million because already C is given in million.
Yes, right. So that's very important thing. Yeah. So whenever you use any calculation, so this is very important. You have to see, you have to be careful with the units. Yeah. If you put these values like we have n equals to 3, I equals to 1.16, C equals to 0.5. So use this formula. So it will be capital cost with 3 multiplied by, because we are not considering this because we have answer in million. Okay. If you want answer in dollars, then multiply with this number. Value of C 0.5. So see, in this formula, the value of C should be MT per day. So suppose if it is not in MT per day, okay, maybe it is an MT per hour, then you need to convert into MT per day. Then only you can directly use this formula. Okay, otherwise, if you the unit is in MT per hour and if you put the value here, then your cost will not correct. So value of C we have, okay, MT per day as per formula also MT per day. So you can put directly multiplied by 1.16. To calculate, you will have 11.2 million dollars. So if you go through this slide, so in this we have seen the formula for capital cost of liquefying the hydrogen production. So the DOE hydrogen and fuel cell program record the hydrogen delivery scenario analysis model, estimate the current capital cost with the liquefiers of varying capacity. So actually this formula is from the DOE. Okay, from they have done some research and they have published the data and report. So based on that, we have a formula. So this formula is based on varying capacity 6,000 to 2 lakh kg per day. Okay.
Do you mean this formula is only applicable for 6,000 kg to 2 lakh kg per day only? Because otherwise, other factor will change.
Yeah, actually they have to derive this formula, they considered these conditions. They have
Correct.
considered varying capacity these. So
Yes.
maybe if your capacity is lower, so
Yeah.
up to some extent, maybe this formula is valid. You need to verify that.
Hmm. Yes.
Okay. Yeah, Chandrasekhar, yeah, we have a query.
Yeah, whatever we have seen till now, most of them are with reference to Department of Energy, that is US.
Yes, yes,
So,
right.
correct. So, are there any such things? These are some of these things are empirical. There may be for their geographical and physical conditions there, but anything with respect to India or any work happening in that direction?
Yeah, currently now we are having NGHM, National Green Hydrogen Mission. So
Correct.
now in India also, many consulting agencies are also working towards or they are making these reports and all. You can find some report based on India also online, and IITs are also working towards this green hydrogen mission and all. But the DOE they are working on this program actually from last so many decades actually.
Yeah, that's
This
correct.
yeah. So due to that, they are having, you know, all the data and reports, and they have
Mhm.
made some standards also. So everyone is following those. But now every country is working. Yeah.
Sorry for digressing. Even BHU is also doing something. Right? IIT BHU, they are doing on these things, or what is it they
So
are doing?
IIT BHU, I'm not aware of that, but
Uh-huh.
IIT Delhi is working on on this field, and IIT Bombay, as you know, Professor
Yeah,
Pratibha Sharma. So she's actively
correct.
working in this, and she's also advisor in the NGHM. Yeah, and
Mhm.
yeah,
Yes.
if you find the report, the country status report on green hydrogen, I maybe this is the title, or you can find it on Google. So
Mhm.
if you go through that report, then you will know so many things. There are so
Okay.
many projects currently running in India, so everything is there actually. You can
Okay.
see you can see the projects, ongoing projects, completed projects, and those who are working. Yeah,
Okay. Okay. Thank you.
yeah. Okay, so next question. Calculate the cost of zirconia chromium ZCr2 in US dollar per kg, such that the cost of zirconia is 96 USD per kg and chromium is 50 USD per kg. So you're given a composition ZrCr2, you're given the individual cost. Now you have to calculate the complete cost for this composition.
For that, we need a molar mass of
Yes.
Okay,
for
so you
both
need molar mass
zirconium
of,
and Cr2.
so I can tell you. So the molar mass of zircon is around 92, I think.
91.22. 5.99.
Okay, so yeah,
91.22 zirconium, chromium is 51.99.
so the molar mass of zirconia is
91.22.
91.22, and for
Chromium
chromium
is 51.99.
51.99. Okay, now you have data, calculate.
Answer is
Whether it will
70.
be given this value in the final examination? this M molar mass of zirconium
Yeah,
and the
yeah.
square 2 and 5.
I think yeah,
You will
you
be
will be
given
given.
what?
Then okay, because very difficult to remember these values.
Yeah, no, it will be.
Not only this, there are so many
So
formula.
many,
I
yeah.
don't know.
Yeah, so many formula, and we also left chemical. I'm not also from chemical background, chemical engineering.
Yeah, if you, because these are the assignment questions, so that's why everything is not given. But in your exam, supporting formulas and maybe this data will be given. The formulas they are very common actually. They will not be given. But if you are the formula is very like hard to remember, then I think they will give you some hint.
The question is, even him will not be able. It becomes a memory test then.
Sorry.
Even if the formula is given or anything, it will become. It will. We can end up in a memory test.
Yeah. Yeah. Right.
And I think it looks like we are not supposed to use calculators, right? Or we can calculate.
No,
I don't think.
calculator is already there. NPTEL calculator is already there.
I
Sorry.
think they will give you inbuilt online calculator. I think I'm not sure.
You can, Mr. You can find from Google NPTEL calculator. You use to this calculator. Otherwise, it will be very difficult in exam directly. Sometimes very difficult because we used to make our hands calculator. Na? So better to try NPTEL calculator through through what we say. The
Yeah,
Gmail,
yeah.
Google, you
So
can
yeah,
find.
yeah. So the good thing will be that you should go through the protocol.
Hmm.
Okay,
Mm.
they said laid down by the NPTEL. So I think in that they have mentioned about the calculator and all. So just go through that.
No,
Those who
no,
are not
that
aware of this thing.
NPTEL calculator is enough for all the calculation. I
Yeah, yeah,
went through.
yeah. So those who are not aware of the NPTEL calculator, so maybe they can find in the brochure of the NPTEL examination and all online. So just go through that and use that calculator so that it will be very helpful in your exam. Okay, come to the question. So anybody, do we have any answer?
71.5.
Okay, nice. We have an answer. B, 71.5. Okay, your answer is correct. So let me give you the formula. So this is the formula. So CA x upon x plus y, MA plus CB, y upon x plus y, MB. Okay. So for the XY, you can say this is the your like metal hydride AXBY. So you can see in our case the A is zirconia, B is the chromium. So for zirconia, X is 1 and for chromium, Y is 2. Okay. So now here XY values, we have given the molecular weight, this Ma, molecular weight of zirconia, Mb, molecular weight of chromium. Okay. Ca, the cost of zirconia we have given. Cb, the cost of zirconia we have given. So use this data and try to solve this. For simplification, you can see both in the numerator and denominator, we have x plus y as a common factor in each term. So just cancel that out. So for simplification, it will become like this. CAXMA plus CBY MB upon XMA plus YMB. So you have value of CAXMA, CBYMB, you have everything. If you put these values, then you will have answer as 71.5 USD per kg. So what is this ZrCr2 actually? So we have calculated the cost for a composition of zirconia chromium. What is this ZrCr2? What it is representing actually?
Is it a catalyzer basically?
No.
Composite hydride.
Yes. So yeah, it's a metal hydride.
Metal hydride, right.
Okay. So we have covered in our previous week's metal hydride. So the purpose of this question, what is the purpose of this question? Okay. The thing is that because we have seen metal hydrides, okay, we have seen complex hydrides and all. So in those we are mixing so many elements. So if we want to calculate the cost, okay, we know the cost of each element separately, but when we are mixing them in a particular composition, then we need to know the cost for our techno-economic analysis. So by this way, we can calculate the cost. Okay. So this is the significance of this question. So by using this method, now you know the cost for this composition of zirconia and chromium, which can be used as a metal hydride to store the
Yes.
hydrogen.
Basically, during the design, what will be cost of the system? We can calculate. Okay. That is also
Yeah,
part of the system.
yeah, because you need metal hydride to store the hydrogen, so you need to know the cost.
Correct. And yeah, yes.
Yeah. So mainly, if we are doing the integration of electrolyzer, metal hydride based storage, and fuel cell system, okay. So then it is cost competitive. Without economics of scale, still it's cost competitive, and this kind of system is already used and under development at IIT Bombay. I think I have already told you earlier also. They're developing two, three wheelers based on this kind of system. No, they are not having electrolyzer actually. They are having, sorry, they're having fuel cell, MH and fuel cell system, not the electrolyzer. Okay, so this system they have, not electrolyzer, or maybe they are working. I don't aware of that, but I'm aware that they are having this system, metal hydride storage and fuel cell system. Okay, and that is cost competitive. So economies of scale can further bring down the cost. The major cost of electrolyzer and fuel cell, the storage system cost is minimal. So this is the major cost. And what is the reason for this? Why the fuel cell and electrolyzers are having major cost component in the system design? So actually the fuel cell and electrolyzers, the material that they are using, okay, for anode, cathode, electrolyte, that's very costly. So due to that only, the cost is very high. And also some other elements are also there, but the major portion is coming from the material cost. So the cost per kg of hydrogen, 2 weight% of hydride is comparable to 700 bar CH2 tank. So, sorry, CH4 tank. Yes, I think it's CH2, CH2 tank. Okay. Solid state storage is safer. Low pressure because we can operate low pressure and move volumetric density and more volumetric density. So the meaning of this, it's compressed hydrogen tank. Okay, 700 bar compressed hydrogen tank. So, but at solid state storage, we don't need this much of pressure. We can operate at a very low pressure as compared to this pressure, and we can still have the same amount of hydrogen. So the overview of storage, the important things are the economies of scale, storage and transportation is very important. How you are storing and what is the method of your transportation of hydrogen from the production point to the consumption point. So if you are using the hydrogen near the production point, then obviously your transportation cost is very minimal. So you can bring down that net cost. So the storage should be sufficient so that we can have the uninterrupted hydrogen value chain. Okay. So as of now, we have seen different kind of storage methods. Okay. So based on your requirement, cost, rate of discharge from the storage, availability of different options, you need to decide the appropriate method. So the compressed and liquid form are widely used. So the majority of 85% is produced on site and only 15% of hydrogen is transported. Short term, the point of export, then the hours of storage, day weeks mismatch between supply and demand. Long term, these are the issues. So for large scale long term storage, we are using geological storage. It's the best option. For short term and small scale, the tanks are the best option. Now let's go through the geological storage. So it can provide economies of scale, high efficiency, low cost. Because the reason you don't have to generate that space, you don't have to maintain that, you have to just only uh, actually you need to uh, see the safety and the input and output and those and some other things also. But actually the the structure is there actually, so you can directly use that like salt caverns. So lowest cost option, you can have $0.6 per kg of H2 with 98% efficiency. So US has largest salt cavern storage. They can have 30 days output for of SMR 10 to 20 kilotons. So depleted oil and gas reservoirs larger than the caverns, but contamination. We have covered it already. We can use this, but then the chance of contamination are there. Water aquifers we can also use, but least mature technology. Natural barrier trap reaction with microorganism, fluid and rock. So still they're under research, feasibility to be proven, and they can provide seasonal storage where salt caverns not there. But these kind of storage are not suitable for short term and small scale storage. Now let's see about the compressed hydrogen storage. So we can have high efficiency, high discharge rate. So when we are talking about the compressed hydrogen, then we need to have a tank that can handle that much of pressure. Okay, and we can have sufficient volume in that. So the manufacturing is similar to CNG tanks, but difference in size, pressure, and production volume. So if we compare the cost of CNG cylinder and hydrogen cylinder, then the major difference is due to the BOP, balance of plants and composites. Okay, the balance of plants like BOPs of account for 50% of cost for low volume. Low volume means 10,000 volume units of production and 25% for high volume. The pressure in hydrogen H2 storage will be around 350 or 700 bar, but in CNG we need only up to 250 bar. So due to this, more carbon fiber composite required for the hydrogen storage. So if we compare type 4, we have covered in our previous classes type 1, 2, 3, and 4 kind of storage tank for hydrogen. So if we compare, if we let's have a type 4 compressed hydrogen tank, so the cost will be $15 per kilowatt hour, and we can have 5.6 kg of usable hydrogen. So in this curve, you can see the cost. So you can see the carbon fiber and BOPs. They are having major cost. Okay, if we want to bring down the cost, so we have to work on these two first. Because if you suppose if you reduce 10% this cost, then that will be significant value as compared to if you reduce 10% of this cost. Okay, so we need to focus on these two. Of the liquid hydrogen, so the cost of liquefaction is for 50 million dollar for 600 kg per day to 800 million for 2 lakh kg per day. So we have covered this already. So we have we know this equation. We can find the capital cost required for liquefaction. So if you see the cost component for delivery, dispensing, then the production, liquefaction. So you can see the major part is coming here. Now solid state storage. So we have adsorption based storage, metal organic frameworks, MOFs.
Brother ಕೇಳಿಸ್ತಿದ್ಯಾ?
Yeah, please mute
Brother
yourself.
ಕೇಳಿಸ್ತಾ ಇದೆಯಾ? ಗುಡ್ ಈವ್ನಿಂಗ್. ಒಂದು ನಿಮಿಷ ವಾಟ್ಸಪ್ ಇಂದ ಕಾಲ್ ಮಾಡ್ತೀನಿ ನಿಮಗೆ. ಓಕೆ ಸರ್.
Yeah, please mute yourself when you are not when you don't have any query, please mute yourself. Okay. So the 5.6 kg of usable hydrogen in dual wall tank with liquid nitrogen flow in between. So then we have other option 165 liter inner aluminum vessel hexagonal heat transfer arrangement. We can have 32 kg of MOF with MOF vessel weight 96 kg. So this type of system is developed at SRNL and MATI. So you need BOPs for filling, delivery, temperature, pressure monitor and regulators, filters, connection for fuel cell and heating. So the cost will become around $6,300 per system for low volume production and $3,052 per system for high volume production. So if you compare the component cost like BOPs, so it will be 53% for low volume and 39% for high volume. So if you use the metal hydride, then this is the formula we can calculate the cost. Okay. We can store the hydrogen at very low pressure as compared to the high pressure tank. So to summarize this, the cost associated with different methods of storage depend on their maturity level. Okay. The economies scale have the potential to bring down the cost much faster than any technology breakthroughs. So we have seen that if you go towards the mass production, then cost is significantly coming down. So large scale long term storage should be geological storage, while for small scale short term we can have compressed and liquid hydrogen options. Which technique is used for inspection of hydrogen transportation pipelines? Carbon isotropy, electrical resistance tomography, seismic waveform inversion, and pigging technique.
Tagging techniques. Digging technique.
Is anybody here from oil sector companies? Any pipeline companies? Okay. So if you have gone through the class notes, please explain your reasoning regarding pigging technique.
Pigging is actually this is required during the first commissioning period. Okay, so after the erection, pipeline laying down or after the welding and all. Okay, so a lot of dirt will be inside the pipe. So a pig is kind of say a ball of wire. Okay, so that is to be moved through the pipeline. So that to move through this pipeline, a machine is used. Okay, so that is called pig, and that this technique is called pigging. So this is normal in any kind of piping work.
Yeah,
This is just like a tunnel boring machine we use in metro to bore the tunnel for train. The similar like a process that use the projectile that is called pig to clean, inspect, and transport the material through the pipeline and tubing something.
yeah, nice. So I want to add one point that it's not. I think you mentioned that it is used after the just commissioning. Okay, so yeah,
No,
it's
no,
true.
not after commissioning. Before the just before the after laying. Okay, after erection, you can say before the commissioning, you
Before
need
the
to be
commissioning.
ensure. Yeah, you need to
Yeah,
be
yeah,
ensure there is
right.
no doubt into the
And
pipeline.
do we also use this after that, after operation?
Generally not, but here I found in the lecture also it says during the maintenance this is to be done. But
Yes, yes.
major maintenance, if you have the major maintenance, that time it might be that I
No,
have not.
actually, yeah,
Yeah.
we use pigging technique initially when you lay down the pipeline. So to check and all to remove the initial welding debris and to clean everything, we do the pigging, the first pigging. So in that pigging, there will be so much of dirt and materials and because I have seen the pigging myself actually. I was in Hindustan Petroleum. So in the first pigging, you will see so much of dirt, materials and everything. Okay. But we also do frequent pigging for the maintenance of the pipeline. Okay, so it depend on uh, like we have in the oil sector companies and those companies those working with those they are having pipelines, so they are having softwares also. So with that, they can monitor various parameters. Okay, and as per the ISO standards and all, so to maintain the pipeline, to ensure the smooth operation, there's we have a picking schedule. Okay, so it vary depending on the parameters. So maybe yearly, 2 yearly, okay, like that. So, but so we do the pigging too for the maintenance of the pipeline. It's not only for the like just
Boring.
in the beginning only. So it is a routine process. So we also have a document. So every company have a document. So they need to fill the document. Okay. So we have done this pigging on this date because they have to maintain their records also. So as per the ISO also, you need to do the pigging. So basically in pigging, if this is your pipeline, okay, so then there will be a this kind of
Uh,
pig will be
this is
there.
this is the same like our in city we using the LPG pipeline,
So the
especially in Delhi, especially in
yeah,
Delhi.
it's yeah actually it's the size, okay, the type of pigs are different. You can mount uh, different instrument also on this,
Yeah,
okay, to
camera, sometimes
yeah,
camera also you can.
you can
So
also
smart
mount
pics.
yeah cameras. You can mount the we have GPS also inside it, so you can track it where it is
Okay.
going. Okay,
Is it underground or maybe elevated
no underground,
over
no,
the ground?
because when we are underground, when we are talking about the pipeline, so that will be below the ground.
Okay.
Under okay, so normally it will be around 2 meter or depth or 3 meter, depend on the like you need to find the level of your uh, based on the pressure drop you need and all. So it will vary.
Yeah,
Okay,
generally it is 1 meter below
yeah. So the
the
minimum is one
level.
meter, and you can go up to 2 meter like that too, and it depend on your pressure drop and the things. Okay, so it will so the dia of this will be very like very narrow gap will be there. Okay, so that it will touch the inner surface. So there will be like the brush kind of systems are also there. Okay, so that will clean the inner surface. Okay, and it will be solid part also. So if there any dirt and like debris, rust and everything, that will come out from the other end. So the question, it will flow with the pipeline fluid itself. Okay, so like when I was in SPCL, so we were having diesel, petrol, and kerosene. So when we are having a pig, so it will come with the current or the fluid that we are having at that time. So it will come with that only. Okay, it doesn't mean that when we are doing pigging, so we will do with it with water only. Okay, so it depend. So the important point is that you can by frequent pigging, you can increase the life of your pipeline, because you know the pipeline laying is a very tough job, time consuming. Okay, and if you are having, and also the maintenance, the outer maintenance is very difficult. If you're if you plan to have a maintenance of the pipeline, okay, suppose, then it's very difficult. If you do the frequent pigging, then it's easy actually. So that's the thing. So it's about the pigging. So it's used
So
for
it's
the
basically like a so it's basically like a piston moving through a pipe, moving through a bore, wherein it
yeah
keeps
yeah
scrubbing the
you
entire
can
pipe.
yeah like that.
Okay.
Yeah, you can
And,
consider, you can just Google some pictures. So you can
mhm.
find some pictures over Google. So that in that you can also see the debris that is coming after the pigging from the outlet and all.
Okay. Out of curiosity, pigging, is there any relevance for the pigging word itself here?
So if you Google the meaning of this, so I think it refer to the, like, let me check.
Okay, let me Google. Sorry, I'm
Actually, something we pushing in the pipe with
Yeah,
some pump or something like that. That is called pig. Maybe some we with put the pressure to in that we are just like inserting something inside the pipe. That is some technology. In YouTube, they are speaking something like pump. We push something pushing inside
yeah,
the
yeah.
pipe. But this is not simple system, very complicated. HPS, solution. So many is there. Intelligent pigging
So you
pipeline
can
is
see
also there.
the origin.
Intelligent.
Yeah,
Hmm.
yeah, yeah.
Rosen Group,
So
Rosen Group, Tekken, so many companies there.
actually, I'm trying to find the origin of this word.
Why do we made him pick?
If highway is present in present in hydrogen transportation, the following declaration
Yeah, so basically, I'm not able to find the exact origin of this pigging word, but now we know it. Okay, so basically, it's for the cleaning, inspection, and like the maintenance of the pipeline. Okay.
yeah. The one answer it what I see, which says is during pipeline pigging, a squealing noise that sounds like a pig squealing arises. Hence, the name pig is given.
Yeah, nice, nice. So yeah, I think this is the true because I also heard the sound. Yeah, so you can heard the sound. Yeah, because you can see it's very actually very there is almost touching each other. So it will, and also it will rotate. Okay,
Yeah,
so because it the flow fluid is flowing, it will rotate and it's brushing the inner surface of the pipeline. So then there will be sound. Yeah.
okay.
So maybe due to that only, yeah, it's considered pigging. Yeah. Yeah. So actually, this thing I was trying to find out. Yeah, why it is called pigging. Yeah. So I think it's true.
No, we'll not forget this.
Yeah.
Okay.
Okay. Nice. Okay. So it's about pigging. So it's a very important technique for pipeline. So as we are discussing about the pipeline, and I also worked there. So just a very basic question. Uh, what do you think? Because you know HPCL, BPCL, IOCL, so they are supplying the petrol, diesel, and kerosene all over the India. So what do you think? Do they have separate pipeline for hydrogen? Sorry, the kerosene separate for the diesel and petrol, or do they have a single pipeline for everything? Because if we mix both, then the combination of that.
I think same pipeline we've
Might
been using.
might be
Yeah.
we use the crude oil directly, then we might be filter
No,
or maybe separation.
crude oil pipeline are different actually. So the thing is
Okay.
that the crude oil pipelines will be connected to the refinery only. Okay, from the
Correct.
port to refineries. From the refineries all over the India, we have a network of pure diesel, petrol, and kerosene. Okay, so the diesel, in terms of oil industry, it is called HSD, high speed diesel, and the petrol called MS, motor spirit. So these are the terms for the diesel and petrol in terms of the oil industries. So we have a single pipeline for all of these, but the main thing is that this single pipeline.
So
Okay.
do
So
you
we have
do
we
the
have to
any
separate.
purging for that after one operation? I mean,
Yeah,
after sending HSD, then you are doing purging, then MS, send MS, like this you are doing?
yeah, yeah. It's very important because if you directly mix the diesel with petrol, then the mix of that will be of no use. Okay, because both are having totally different properties. If you mix both, then it is of no use. And the pipelines are very long. Suppose if you are having one trench of diesel HSD, okay, it's going. Okay, and the pipelines are like, you know, in like thousands of kilometer. Okay, depend on the location to location. So, and the flow rate also 400 kl per hour, 500 kl per hour. It depend on the dia and the capacity that you can have. So see, you are having one trench of HSD, and then now you want to supply the petrol. Then what will you do? You will start the pushing petrol. Okay, then this is a starting point. So this is your trench of petrol. Now you know the both will mix at this point. Okay, now just imagine the distance. So with distance, with the flow rate, this interface will start increasing. Hello, am I audible?
Uh, yes, now, but we missed a little bit 1 minute before what you said actually.
Yeah, I think I was having some issue. Okay. So the thing is that this is called interface actually, where we are having the mix of two, because with the speed, with the length of the pipe, they will mix together. So this interface, okay, the mixture of the diesel and petrol will be of no use. So it is not the way. So the way that the we follow, every industry follows that whenever you want to have the diesel and petrol, in between you will have kerosene, because kerosene you can add in both and it will not change the property so much. Okay, so what will happen? This is your pipeline. Okay, so you have this trench is of your diesel, then you will push the kerosene. So
Do
now
you
you will
mean
get,
kerosene will always be in between petrol
yeah,
and
in
diesel?
between, always will be in between. Yeah, so you will put
Hmm.
kerosene and then you will put motor spirit or petrol. Now you will
Okay.
calculate how much of this kerosene you will need. You need to calculate it.
Hmm.
Okay, it will be based on the length of the pipeline and the flow rate. So they have some calculation with them. So they will calculate, okay, so we need to push this much of kerosene so that this interface will not be that much. And we can have pure kerosene in between, and this diesel and petrol will not come in, like they will not mix together. Okay, yeah. So this is the thing how this work. Now this you can, uh, like you are having the location there, you are having separate tank for this. So then you will separate, because you can track you can track this. because the density difference is there. Okay, so you can
So there is some tool on sensor, something is there that can
yeah,
find
yeah,
the difference between the diesel and kerosene.
yeah. So we are having, so at the location where you are having your receiving point, so there you will have online density meter and everything,
Mhm.
and also you will measure manually there. You will have sample points, so you will frequently measure the density and see the density will because you can see the mix will be there, so the density will start changing. So actually this is very important part, it called interface interface handling. So it's a very important part in oil industry whenever you are in the pipeline operation. Okay, because if you don't switch on the right time, because suppose currently my flow is going in the HSD tank. Okay, so in this tank I need only pure diesel. I don't want to have the mix of kerosene also. I have three tanks. One is four tanks. One is the diesel, then the mixed tank in which I can have both mix of kerosene and diesel and the kerosene and petrol. One is for pure kerosene and one is for pure uh, petrol. Okay, so I
Okay,
need to
if we
change. I need to change the tank exact
Mhm.
time. Okay, precisely. Otherwise, I can I can change the properties of whole tank actually, and that will be and that tank can fail in the quality test, because whenever you have any product, so that should have the proper quality. Okay, the cetane number, the everything, the octane number, cetane index, those indexes and all. So they need to have exact uh, data per standards. Okay,
so
so
nowadays we are
this,
not using kerosene. So kerosene is the only purpose of separation, nothing more, na? Because nowadays kerosene is not in application. Maybe I don't know in whether CT or
yeah.
not. Only for separation
So
purpose, right?
yeah, mainly it is, no, it is used actually. So there are so many. You are, maybe you are not using. I am not using, but yeah, it is still in the use actually. Yeah,
Okay, okay.
yeah. So kerosene in diesel, you can, if you mix 2% of kerosene, there will be no difference, no major difference in your diesel quality. And in petrol, you can have 1% of kerosene, and you will, there will be very minimal difference in the quality.
What about ATF?
Okay, sorry.
ATF, aviation tube for ATF.
Yeah, yeah. ATF actually, yeah, yeah. For the ATF also, so uh, in my plant we were only handling HSD, MS, and kerosene. So for ATF also, so normally for the ATF you need to like do this kind of thing only. But sometime for ATF is not transported through the long like these uh, very long pipelines. So, but the interface handling about ATF, I don't know exactly how they handle that. So I cannot comment on that. So because we were having 1060 kilometer of pipeline. Okay. So let's
But
move
for
further.
India, this is nothing.
Yeah, for India it's nothing actually. Yeah. So I was working in the MDPL Mundra Delhi pipeline. So we were receiving the products from Mundra port and we will delivering to Delhi.
Mundra means
Yeah,
Gujarat.
yeah,
From okay, Gujarat to
Delhi.
Delhi. Okay.
And that too in the um, high temperature zone. So at what depth these pipelines used to be then?
So
For example, if you are coming in through Gujarat, you'll be at
so
a very
actually
high temperature.
The depth I don't
The
know
surface
there
temperature
actually.
look pretty high.
Yeah. So the temperature, because we are dealing, it will not affect that much, no? It's in pipeline actually. So when you are only measuring at the source and the location, if the density will change in between, okay, but at the end you are getting all the product.
In between, we use the compressor because we don't, we cannot use end to end. Na? We, might be use the intermediate compressor to push the
So
liquid
there
or
will be
maybe
so many
gas.
intermediate station. Yeah.
Okay.
Okay,
Mhm.
stations. Okay.
The
But
reason why
now
I asked,
you will control the pressure as well, monitor the temperature and pressure, everything.
Yes. You need to control the pressure and everything. And there also
Mm.
like there are so many like I cannot say organization. So there are so many people, those who are trying to steal the through the
yeah,
pipeline. Yeah.
correct.
So that's why the pressure is very important to monitor. So because
Mhm.
pipeline is totally pegged.
Hmm.
Okay, you have one inlet, one outlet. So the pressure monitoring is very important. So the software that I was talking about, so that software basically work on the pressure. Okay. So he sends pressure through the pipeline. If there is sudden pressure drop, okay, and uneven pressure drop, then he detect, okay, there will be some leak. Because if your fluid is flowing through pipeline, then the pressure drop should be as per the elevation, the friction, and all as per those things only. Okay, you will not see a sudden pressure drop. Okay, so yeah,
Stealing of the this type of petrol or diesel is very hazardous for a human. I think so because it's not like a water those spread split
the
out
thing
and
is
okay.
the thing is that if you are not a professional, because the pressure in this pipeline vary, so it can be 10 bar, 20 bar. Okay, it depend on the location and the pipeline. So if you're not a professional, if you're trying, then yeah, it will be a like accident actually. Yeah, and also it the area, it is also difficult for that area actually. If there is a real leak, okay, but it's actually underground, so it will not affect directly, but the person who is trying to steal, okay, trying to uh, make a what do you say, make a punch on the pipeline. So it's very difficult for that person. But actually, in past, so many things have happened to the pipelines. If you find reports, then you will find some incident, some stealing incident from the pipeline. So there are so many professionals, you can say, in this
So
stealing. So they are having
what
their tools and all. Yeah.
one of the known situation what they had done was there was during a regular maintenance period there you drop your pressure. At that point of time, they punctured, they put a hole and a valve. So as soon as they increase it, they were siphoning it out from there because when
Yeah.
the system pressure is there, you can't. So these were all hand in glove people. They were all hand in glove.
Yes. Right.
This all,
Yeah. Okay. Okay. So
yeah.
I think we have discussed more than the time was required for this question. Okay. Okay. Let's move further. So for transportation, we have so many routes: pipeline, dedicated hydrogen pipeline, or natural gas pipeline. So either you can have a dedicated hydrogen pipeline, or you can already use the natural gas pipeline. So because we have all over the world, the NG pipeline network is huge. Okay, in the like millions like of kilometer. But dedicated hydrogen pipeline is only around I think 5,000 kilometers. So it's better to use this network. And if you are thinking about uh, to have a new hydrogen pipeline network, then it's very difficult because you need to. It will take time. It's difficult, but it can be done. But the thing is that time. Okay, time is money. So you need to have so many permissions, right of ways, and all things. So many things are there. Then you can also have tube trailers. You can have compressed hydrogen. You can transport via ships, liquid hydrogen, ammonia, LHC, then road by vessels in liquid hydrogen. These are the routes. So if you are from industry at 20 bar, okay, then you can either supply it to the distribution pipeline, okay, to an intermediate uh, compressor where you can compress it, and you can transfer it to transmission pipeline, or you can store it for hydrogen storage for the compressor for the storage. You can directly have this pressure from the electrolysis. You can put this into you can also have this in the pipeline. Then if you are using for the customers in colonies and all, so it should be less than 10 bar. For fueling station, you can supply it there, and you need to further compress it up to this bar. Then you can fill in the vehicles. So for the natural gas pipeline made of carbon or stainless steel with dia 4 to 48 inches, high strength steel used for energy transmission pipeline and greater than 100 KSI. Low strength steel is recommended for H2 transport because for high strength there will be hydrogen embrittlement issue. Okay, so low strength steel API 5LA, B, X42 and X46. These are the examples. Pressure 0.34 to 10 megapascal, dia 25 to 30 centimeter. Unprotected steel pipeline are more susceptible to corrosion, so that we have a cathodic protection. It's very important. So for the pipeline, you have a cathodic protection system so that your pipeline will not corrode, because you know your pipeline is buried in the underground. So it will be corroded. But we have this system, so you will have a separate material that will be corroded instead of the pipeline. So you will be like having some connection with the pipeline to that material. You're sacrificing material. So all the thing will go to that only. So pipeline laying, trenching, there are methods like you can do the trenching, boring, horizontal drilling, horizontal directional drilling and all. Welding of pipeline. So welding is very crucial for pipeline. Your joint should be seamless. Welding and testing is more stringent in hydrogen. Side booms quality checks are important. So operation and maintenance is very important. Smooth functioning through advanced automated systems. Detect leaks, prioritize maintenance and repair schedules. Inspection device help monitor pigging technique, instruments, smart picks. So it can smart picks will generate a report, so you can find like cracks, deformation and corrosion. So existing equipment and concept for NG pipelines can be adjusted for hydrogen pipeline transport with minor alteration. But still we will have challenges for safety, gas velocity, walls and hydrogen embrittlement. Okay, walls because density difference is there. Okay, velocity will be different because uh, due to also the density issue. The magnitude of energy input required to transport hydrogen is space times higher as compared to natural gas.
It is 4 times.
Okay, 4 times. Yes, it's correct. So the energy input required is 4 times higher as compared to the natural gas. So hydrogen take 4 times more energy to move through a pipeline than natural gas. Because volumetric energy density of hydrogen is 3.29 times lower than of methane. Operating pressure of 70 to 100 bar, the aerosol velocity can be 2.91 times higher than methane. Max flow rate of H2 can be 2.91 times of methane. So maximum energy density we can have 88.4% of methane pipeline. So we need higher flow rate so that higher compression energy, 3 times more energy to compress a megajoule of energy if to supply is hydrogen than supply is natural gas.
So yeah, here is methane means we're talking about the natural gas, right?
Yes, yes.
What does it mean by this maximum energy density of H2 pipeline equal to 88% of energy content of methane pipeline?
So I think so because we have the flow rate constraint, okay, like the max flow rate that we can go like 2.91 times of methane, okay, because after we also have this pressure constraint and all. So based on I think those constraints, if you find the energy density of a methane pipeline with the full potential and compare with the hydrogen pipeline, so this is the comparison actually. So the maximum density, the energy density for a pipeline will be 88% of methane pipeline. Okay.
So it is coming 2.91 divided by 3.29. If we do that, then 88.4% is coming. So
Yeah, nice. Okay, so that the maximum energy density of H2 pipeline will be 88.4% of energy content of methane pipeline. So in terms of blending hydrogen with natural gas, what would be the impact at end use? Gas volume required to meet energy demand will be reduced. Gas volume required to meet energy demand will increase. High volumetric energy density can be accomplished. Reduce infrastructure cost.
B.
it will be B. Gas volume will be increased.
Yes, by
Have you asked anything?
yeah, why it will increase?
Yeah. So a volumetric, uh, the energy content in unit mass or unit volume of hydrogen is lesser than the methane. So to get
Yes,
at the end user to get the same energy, so more flow needs to be required.
yeah. So volumetric density is playing the role. So the blending hydrogen natural gas, so it can save significant capital cost because we have already very large engine network. We will not have to develop new infrastructure for the hydrogen pipeline. We can directly blend it. So at low level of blending, you don't have to do major modification. With minor modification to operation and maintenance of pipeline, you can do it. More significant issues for higher blending, 15 to 50%. You need to have conversion of appliances and to increase in the compression capacity. Blending above 50%, there will be more challenges in multiple areas like pipeline material safety modification at the end use. Okay, so depend on the blending percent, the changes will be according to that. The blended hydrogen either can be used as such or separate before delivery. So either you can directly use the blended hydrogen or you can also separate it. Possible option during early market growth and can provide alternative mode in long term. Okay. So natural grid, high capacity, well established safety measure, operation strategies. We have control and maintenance procedure are there. Public acceptance is there for natural grid, natural gas grid, NG grid. Broader geographic availability and interconnectivity. So I think now all over India we have NG network and we have NG grid. Limit of blending depends on existing pipeline design infrastructure. The limit will depend on the pipeline material because we know there can be embrittlement, the pipeline thickness, okay, and the age of the pipeline. Okay. So you need to consider all the factor. Then only you will have okay. I can blend this much amount of hydrogen in the NG pipeline. So if we convert the fully like NG pipelines to dedicated H2 pipeline, still we can reduce the 20 to 60% of cost for the new dedicated pipeline, and it have multiple advantages. Please mute yourself, Sudeep. Okay, I request you all please unmute yourself whenever you have a query or if you want to discuss something. Otherwise, mute yourself. Okay. So the challenges in blending. So we have reduced energy content of delivered gas, greater gas volume to meet energy need, H2 burns. Okay, maximum limit of blending with lowest tolerance. So let's go to the question first. I think we have question. Then we will, if time will left, then we will come to this. So what is the factor of safety taken for carbon fiber based composite vessels?
3.25.
2.35,
2.35. 2.35.
The correct answer is A, 2.35. What is factor of safety? Quickly.
It is basically material property. If I need say 100 kilopascal or KSI, then I should go a material which is giving at least 2.3 2.35. This is the margin over the design, the requirement actually.
Okay. So factor of safety basically meaning that okay, your operating pressure is suppose 10 bar. Okay. But your pipeline material should be able to handle 10 into 2.35 up to 23.5 bar. So this is the margin. So 10 to 23.5. So 13.5 bar you are keeping as a margin. So up to this pressure, your pipeline will not fail. Okay. Your material will not fail. This is the factor of safety because this is chosen because when we are having pipeline, suppose your pipeline is connected like this, you are having your input here, output here. Okay. And you are collecting this output in your tank. And due to any problem, there is a wall. Okay. It's open and flow is going into this tank. And due to sudden any issue, this wall is closed. But this point is pumping the flow continuously and the flow rates are very high. And what will happen? The flow will start accumulate in this pipeline and pressure will start increasing. Okay. And there will be sudden rise in the pressure. Then if you're then there should be some limit. Okay, up to that this pipe can handle the pressure. Okay, but in this case the pressure can sudden rise, but the pipeline will have so many safety systems so that in the case of any rise there will be some other wall and all. So there is a second case, but the basic meaning is that your material should have extra strength. Okay, so that is a factor of safety. Now tube trailer delivery. So we can also deliver the hydrogen via tube trailer. So we have hydrogen from transmission pipeline. We can compress it. We can store it. After compressing, we can fill these into the cylinders in loading bays. Then we can deliver via tube trailer delivery to the fueling stations. Okay, like you have seen the CNG. Okay, CNG is the tube trailers and CNG dispensation. You can see there are cascades, filled cylinder connected in series, and they are filling to the vehicles. So demand, when it is used when demand is low, production plant is closely located. It's only useful in this case. So we can have tube trailer delivery. Okay, so important parameters: material size, packaging of pressure vessel. Okay, arrangement, like you can arrange like this, or like this. So by changing the configuration rule, you can save up to 60%. You can decrease the cost by 60% by optimizing configuration and payload. So we have also steel pressure vessels. Okay, for this factor of safety is 3 to 3.5. So increase in the pressure is increase in pressure to increase payload is not effective as weight increases, and due to that due to wall thickness. So for composite vessels, factor of safety is 2.35. So in composite we have carbon fiber, so it have higher strength, lower density. So it have lighter, thinner walls for a given pressure, higher payload. So you can have 1100 kg at 500 bar pressure. For steel, the factor of safety is 3. For composite, 2.5. So shape of pressure vessel is hemispherical. So if you compare the cost of steel and composite vessel, so you see the difference. So the composite is very costly. The cost of steel vessel include material cost, 80% for steel and 40% for composite, and manufacturing cost 20% for steel and 60% for composite. And for empty trailer 50.5 lakh, it's only for this example, not like a fixed data. Challenges with tube trailer hydrogen transport. So higher payload requires higher pressure, low density of hydrogen. Okay, testing effect of pressure cycling, cold gas, high energy density and lower pressure. We can have high storage cost.
In India, do you have any company who is manufacturing these hemispherical vessel for this hydrogen
Actually,
use?
I don't know about the company's name, but you can try to find.
Okay.
So refueling nozzle in dispenser are built upon which standards? SAE J2601, SAE 2799, SAE J2600, TSG 212016. So answer is already there. Option B is correct. So we have some standards. Based on that, you have to make your system design. So for the refueling nozzle in dispenser, by which you are filling your car, so there are some standards which you have to follow for this nozzle. So that is SAE 2799. So for the seamless steel vessel,
That
the
is
stand
SAEJ 2799 or J is missing. I don't know.
no SAE 2799. I think yeah.
Okay, there is no J. Okay.
So seamless steel vessels designed as per ASME standard and TSG 212016. So they are standard for the seamless steel vessel for high pressure storage. So for dispenser, the standard is SAE J2601 for fueling nozzle, SAE 2799, the refueling connector, SAE J2600. Okay, so three standards are there for the complete dispenser. For an alloy to be categorized as high entropy alloy, the configurational entropy should be greater than or equal to 1.5 R, 0.5 R, R, 3 R.
It is $1.5.
For what this is standard SAE 2701?
So you have to check it online.
Okay, 2601. Okay, that is not given here. Only
Okay, so anybody? We have covered this in our first slide, first or second slide.
1.5 or
1.5.
5.
Okay, so the correct answer is 1.5 R. So yes, so if it is greater than 1. Equal to 1.5 R, it will be the higher entropy alloy. Is in between 1.5 R and 1 R, medium entropy alloy. Can less than R, then low entropy alloy. The atomic size difference for multi-phase high entropy alloy should be okay. The answer is 6.6% to 9%. So atomic size difference can be calculated using this formula, and it should be in this. So for amorphous, it is greater than 9%. Multi-phase in between, okay. And for single, less than 6.6. The question was asked about multi-phase high entropy alloy. So the answer is this. If it is asked about amorphous, then it will be. And if single, then it will be. The chemical formula for complex hydride is
T.
Complex hydride, no, it is C.
yes. So the complex hydride formula is this.
Yes. C X may be metallic or non-metallic. M
Yeah.
metallic.
Yes, yes.
Which method is preferable for large scale and long term hydrogen storage?
Definitely geological.
Geological.
Yeah, because we want to have long term storage, then the best is the geological storage. Which is the major cost component in a type 4 tank? Resin, balance of plant, BOP, or carbon fiber, liner material, and manufacturing.
Carbon fiber.
Yes. You can see here The 62% cost is due to carbon fiber and 25% is due to BOP. Which of the following is not a cost-effective option for hydrogen transport via ship?
Gaseous, right?
Gaseous.
Because due to volumetric density.
Because because volume is very high in case of gas form and ship is not sufficient to ship.
So via ship, the preferred route are liquid, NS3 and LOHC. Okay. So in the shipping, when it's used to ship the hydrogen, so if you have the boil off losses, then the hydrogen those losses will be used for power generation. So it require a lot of infrastructure. So the cost is actually concerned because if you are having if you are transporting hydrogen via ship, then what will happen? So when it's going with the hydrogen, so that time it was filled, but when it is coming back, then it's empty actually. So due to that, the cost is a concern. So this is the first liquefied hydrogen tanker. You can find more about this. So it is developed by the Kawasaki Heavy Industry Japan. The tanker is 116-meter long and can transport 75 tons of liquefied hydrogen kept at temperature of 20 Kelvin. So import from Australia port too. So it is importing. So Japan is and to Korabe. Which type of steel is recommended for hydrogen transport? High strength,
Low,
low strength, high
low,
carbon,
low,
high manganese.
low strength.
Yeah, so we should use low strength steel. Okay. Due to the hydrogen embrittlement issue. Which flow equation is used to calculate the pressure drop in pipeline for hydrogen transport?
Bernoulli's
Stokes,
equation.
Darcy, Bernoulli's, Brinkman equation.
It is Bernoulli's.
Which flow equation calculate the pressure drop? Pressure drop means maybe Darcy law.
Darcy is for liquid. This is for yes. Bernoulli's is for all fluid. Bernoulli's equation here.
Yes, correct. The Bernoulli equation is used for the pressure drop in pipelines.
Yes.
So the parameters that can drop the pressure that can also affect the pressure: length, roughness, control valves, branching, and elbows. So you have equations that can use to measure the pressure drop. Okay, so for more detail, you can go through the class notes. Separation of hydrogen from a mixture of hydrogen and natural gas at the end use may increase the hydrogen cost by what amount?
Maybe C D. Oh, no, I don't remember.
It is.
Oh,
It is
C,
A.
C, C,
A. It is
C.
A. It is A.
In rupees,
A dollar, what is the USD?
the difference between A and D is A is in
uh,
rupees and D is in USD.
then D.
Yeah. So yeah, it's true. Answer is D. So
Okay.
for the separation of hydrogen from a mixture of H2 and natural gas, you have to spend some extra money. That will be around 0.3 to 0.4 US dollar per kg H2.
Hmm.
So regarding the blending in UK, they have a study by which they are claiming that their appliances can handle 23% of blending. Okay. And so the seals of, but also when we are using hydrogen, then we need to consider the seals. So seals of a gas turbine can only handle up to 5% of blending. Okay. And 2%, and you need minor, you have to do the minor modification for these also. For higher blending, you need to have new equipment. So natural gas is internationally traded, so uniform blending limit is essential. So actually we are having this internationally traded so that we should have a uniform blending norms. So there is need of standards to address higher blending later, and policies to be in place to increase the blending, replacing appliances, etc. Separation of hydrogen at the end use site cost increased by 0.3 to $0.4 per kg H2. Cost of separation and recompressing natural gas. What is the percentage cost distribution ratio of material and manufacturing cost for composite vessel used for transporting hydrogen via road?
It is 40-60.
Okay. Okay, have this question was also covered, these questions were covered in the previous class? The other class for this week?
Yes, yes.
No,
I think few slides before you discussed here.
Okay.
Yeah, for in case of steel, it was manufacturing was material was 80% material cost, and the manufacturing cost is 20%. But in case of composite, it is uh, I think 40%, 40-60. Yes.
Yeah, nice, nice. So yeah, it's the answer is option B, 40-60. So we covered this in this slide. For the composite pressure vessels, the cost for steel vessel include material cost 80% for steel and 40% for composite. Manufacturing cost 20% for steel and 60% for composite. The question asked the material and manufacturing cost for composite. So for composite, 40% is material cost and 60% is manufacturing cost. So 40 and 60 is the answer. And other possible, so today we have covered the different methods for hydrogen transport. Okay. And there are also other methods are there. They will have their own pros and cons. Capex and OPEX different will be there. Okay. So in summary, we can say the final cost to end user. That's important. Okay, because at the end the user is paying the amount and you are recovering the whole supply chain cost from the user itself. Okay, so that's important. So the final cost is very important. What is the final cost of hydrogen? Through different routes, you have to minimize that. Okay, so different modes of transport, different conversion, transmission, distribution, storage, and reconversion costs. So these are the thing that you need to cover. One option may be cheaper for a specific part of value chain, but expensive for another part of value chain because value chain is quite long. So you need to consider each part. Maybe one part is uh, cheap, but maybe that is expensive for the other part. So different technologies are available, but they are at different maturity level. So if you are considering, okay, the cost will reduce if you go for mass scale, but that also depend on the maturity level. So in land hydrogen transport, like transmission distribution via pipeline, cheaper till 3,500 kilometer. Above that, ammonia is cheaper. Okay. So between ship and pipeline, H2 dedicated pipeline cheaper for below 1,500 kilometer. above NS3 or LOHC by ships cheaper. So different countries may have different cost scenario. Japan imports 90% of its energy need. So it depends on the country to country also, because Japan, the import is cheaper than the production. Okay. Trade-off between domestic production and imports, there should be trade-off. Because if you are producing a system and you are spending 1 rupees and the same thing you can import less than 1, then what do you prefer? You will import that. Okay, so these are the things that you have to consider. Okay, I think we have covered enough for today's class. So that's all from my side. Thank you everyone for attending this session. So
Okay. Thank you very
yeah,
much.
thank you. So
Thank you.
next
Thank you.
session, yeah, thank you everyone.
Thank you. Thank you, sir. Thank you.
So if you have any query, you can email me on this email. So I will try to respond as soon as possible.
Sure. Thank you.
Thank you.